Me now introduce Senthil Kumar to this session. Senthil is an amazing individual with a lot of passion for education and technology. Senthil has done his post-graduation in management from IIM-Kozhikode and has also done his MS from the University of Warwick. Senthil is a perfect role model for all those who are trying to build a career or are passionate about technology. In his career spanning over 15 years, if I'm not going a little wrong, he has grown across verticals, right? And started off with hardcore tech companies and now consults some of the largest organizations on how do they leverage technology and how do they grow with it. Senthil, I would like to welcome you, and if you can just switch on your camera and your audio. So, it's a pleasure, and I'm sure all the attendees, which includes students, there are some parents, and a few educators as well, as part of today's session. The stage is all yours. You have the. I'll stop my screen share, and then you can bring in your presentation, please.
Thank you for the very, very humbling intro that you gave me just now. So let me welcome all the participants on Sunday. That shows the kind of value that they want to, they are giving towards their career and what they want to understand about data sciences and artificial intelligence, recent developments that I will be talking about. I'm going to share my screen in a minute and then we can start. All right, so let's begin the session right away on data sciences and artificial intelligence. So right now I lead what is called as the emerging technologies consulting, and we typically look at what are the new technologies that are on the horizon. Some of the very key technologies that we are looking at is data sciences. Artificial intelligence is a higher level of data sciences right now. We also look at IoT, cloud technologies, which are evolving really fast. And right now, there's a lot of traction for cloud technologies. We also look at blockchain and augmented reality, which are all starting to gain significance, and people are really understanding how they can use them in their day-to-day lives. So when I say day-to-day lives, when it comes to technology, at any given point of time, I've been seeing technology for the last 15 years. Arun, you're right in that place. 15 years, any technology has gained traction or made sense only when it got acceptance in the business community. And when I say it has relevance in the business community, it means that if I use this technology, I am either going to save money or I'm going to earn money. As simple as that. That will happen if most number of people are going to adopt that technology. There are many technologies that, nowadays, there are a lot of very, very innovative technologies that keep coming in into the market, but the adoption of such technologies is directly proportional to the value that it is creating in the marketplace. So data sciences and artificial intelligence, I will speak only about that today, and I will give you a view of what is this and why people started adopting artificial intelligence, or where is data science? Is there artificial intelligence already around you in your life right now? So these are some of the things that we will be speaking about. And of course, there's a lot of doubts and questions about how artificial intelligence is going to affect the job industry. And that's something that, we will touch towards the end. And without much ado, let's get into our first slide where I'm talking about what is data. So classically, data is defined as anything that represents anything, right? So it could be a number, it could be a description, or it could be a prose or a text. Anything is a data. In 10 years back, when somebody said there was a data, we had a very clear distinction saying that either it could be a number, or it could be a character, or it could be a sentence or a word. But today, the data could be a video, data could be a photograph, the data could be an audio file also, because we have the ability to understand, or the machines have developed the ability to understand what is going on in a video or in a picture or in an audio clip. So all of them are today classified as data. And so the definition naturally became then how do I say that this is a data? So anything that gives me information, or again, to use the same word, data points, to make a decision, becomes a data. So in this picture, I'm showing you that there is a teacher who is teaching, and then there are questions, dialogues, surveys through which the data is collected. And then at the end of the day, the student is said that either he has passed the exam or failed the exam, or which means that he has understood the subject or he has not understood the subject. So anything that gets transferred in your classroom from your teacher to you, or from you to the teacher, the conversations that happen in the classrooms, they all culminate towards making one decision, which is, do you understand the subject or not? So that's a very basic way of explaining data, where I'm saying anything that leads to a decision. There is a traffic signal, there's a green light that comes in, and then I need to start. There's a red light, I need to stop. The green light and red light are my data points, right? I need to go fast, I need to press my accelerator. I need to go slow, I need to stop, I press my brake. So my speed odometer is going to show me the speed, right? So that's a data point. So anything that lets me take a decision is a data point. Now, even 20 years ago, 15 years ago, or even 10 years ago, this was not a big deal. The data was always a number, the data was always a character or a word, and all computers were happy dealing with it because it was fairly simple. These are the only two types of data that gets collected into into a computer. As the speed of computers progressed, the data that gets generated in the systems, they started proliferating, right? So 15 years back, when YouTube was started, nobody thought that there is going to be so much of video that gets uploaded. In fact, nobody had so many cameras, digital cameras, to capture videos and upload into YouTube. Then slowly we started having smartphones, and people started taking videos all over the place, and then they started putting on YouTube. Then people realized that, okay, there's too much amount of video, but I don't know what is going on in this video. And it is physically, humanly impossible to look into each of the video that gets uploaded into YouTube to just say that, okay, this is good content, this is bad content, this is useful and this is not useful. Just to make that classification, it was almost impossible for human beings to sit and go through those videos, even though in the initial time frame, that is what they did. So somebody said, okay, let me write a program that identifies what is happening in the video. And that is when we started processing data. Another thing that happened is that on one side, you started creating so much of data in the form of video, in the form of any device. For example, people started telling that, okay, let me find out if the water is going to be available in the pipe or not. Let me find out if my lights are on or off in my house when I'm not in town. Let me find out. So the government said that, okay, let me find out if all my traffic signals are not working or not. the government said, let me start putting cameras across the city and see if people are violating traffic signals or not. So all these devices started generating data. And on one side, the devices also became cheaper, right? So if 20 years back, nobody had a smartphone, now everybody has a smartphone. If not one, they have many smartphones in their hands. And then all these smart appliances became cheaper. And we all know that, everybody who's plugged onto a digital world has a laptop, has a camera in the form of a mobile phone, and they have a tablet. Probably they have a car um, which is collecting data about its engine and sending it to its manufacturer. All our aircrafts are constantly sending data to our satellites and to their manufacturer. Buses are sending data about where they are to their commuters. So all these is possible because the cost of these hardware became very, very low in the last 10 years. The transfer of data became really cheap. The networks, the mobile networks on which this data is being transferred is ubiquitous. Almost 99% of human population across the planet is covered by mobile signals right now. So there's hardly any place except for those nooks and corners in your house where you really need to sit and take your mobile phone calls. Everywhere else, its mobile phone signals are available. So when this much amount of data is getting generated by all these devices, this much amount of data is getting transferred over those networks to somewhere. Let's call it as somewhere right now before I jump into what it is in the next slide. All this is possible right now because the cost of network and the hardware devices have come down. And now what do I do with this data? There's an amazing amount of things that I can do. People said that, okay, when somebody walks into the store, I know that he's walking into the store is because his mobile phone will send that this person has walked into your store. So when that happens, let's give him a promo. So when they said that, okay, let me give a promo for that guy, that becomes a business value. So people started saying that, okay, I need to have this feature. Then you have this data coming into the cloud. There is huge amount of storage that is available in these cloud systems. The cloud systems are nothing but the picture that I've shown here. It's an array of servers. It's like racks and racks and racks of servers which are connected to a network. All the data that gets generated from millions and millions of devices across this world go and sit in these huge servers. They have huge, really fast compute power, and then they have amazing connectivity. So data goes and sits in these servers. There is processing part that is going to look into this data. It is through those clouds that you have your Play Store, your applications, your games, your VR videos, your YouTube, your Netflix, everything is coming from these kind of systems and clouds. We call it as server farms. Basically, hundreds of servers, and we ensure that they are all operating at the right temperature, secure, they are not having network issues and so on. Now, all these are happening because these networked servers are sitting somewhere. Now, if I need compute power, I need huge amount of storage as an individual, all I have to go to is to go to one of these cloud providers and say that I need X amount of compute, X amount of connectivity, and it's mostly available for free right now. You can get that access. 20 years back, that was not possible. If somebody had to do a program, if they want to crunch a huge problem, they need to physically go and buy a server and come home and do it. If that guy wants to do that for only 2 months and he's done with the work, he will not know what to do with that server. Or in those times, it's called a computer, right? That desktop computer. He will not know what to do with that desktop computer. Today, nobody needs to bother about it. I need to solve a problem, go to these guys, take some data, take an account with those guys, put the data, do the processing, and get out. Now, what essentially have I done here? I had data, I had some compute power on it, I wrote a program, and I got some output. This output is essentially to understand the data that I put into the server in the first place. Millions of students writing exams, I put it into the system, and it's going to tell me whether they have understood the subject or not. Millions of parameters about wind, temperature, wind velocity, cloud movement, and everything, that I go and put into the server, that is going to get reflected as your weather app in your Android phone or an iPhone. When you call Siri and say that is it going to rain today, and Siri is going to say there's going to be 20% chance of raining in your area, what it has essentially done is it has understood the parameters that has been uploaded to its servers about your area, and it is throwing out the decision, and the decision is whether it's going to rain or not. And most of the times it is correct now, because we have really understood how to predict some of these things. Google is almost always correct about the route that you should take to reach a destination. It's almost always correct about the traffic patterns in the, when you go in that route. How is that possible? These are all data that got processed and the computer understood it, and then it is giving it to you. So I have not mentioned about cloud compute, but I've explained whatever I've said about how this data is getting processed is through clouds. Cloud, which is nothing but since these servers we don't even know where these servers are. This could be for large companies. We have seen that they have cloud farm in Mumbai. The closest for many big companies are in Singapore. Likewise, there are smaller data centers or cloud farms spread across the world. We don't have to know where they are, but they are always there, always connected, and we should be able to connect to them. And even if we are not able to reach to the nearest cloud, they have created parallel systems so that you will not even know that some machine is not working. That's what happens when you log into your Gmail or your now this is not there, the Yahoo Mail or any online mail system that you do. There's hardly any time that you would have seen it is not available. Take Flipkart or Amazon or Snapdeal or any of these systems. IRTC website where you book your rail tickets, they are almost always never down. That is because the moment, and it's not that they will always be available. The systems are bound to stop. The systems will have their own issues, but they have created enough amount of compute power replicated in different places so that if one system goes down, the other system will take care of the load. Right? It will start serving those data. It will start processing those data so that you will not even know that something is not available. So this is a huge field that is gaining popularity in the last 7-8 years, and people are I would say that just scratching through the value of this kind of systems. So the traditional IT where you have a laptop, you have a desktop, you go to your office, that's going to be a server room, is fast disappearing because people have realized that I don't need to have so much of servers in my office to do anything. All I have to do is call up one of these large companies which run these data farms, and all I have to do is to subscribe to them, and then I get all the access for data, for compute, for connectivity, for processing, for softwares as well. So even I don't even need to buy softwares. It's going to be available there and I can subscribe to them. So now what has essentially happened is these IT engineers that we have seen in the last 20-30 years who have done really well in India, they are all now moving towards this place where they still write programs because these cloud systems needs to be managed. The programs that you still see as Microsoft Word and PowerPoint and 1,000 other business applications, even the one that we are using right now, Zoom, all of them needs to be still be programmed. It is just that it is not going to be done in a laptop or a desktop of an IT engineer, but in one of these servers. He is just going to log into one of these servers and he's going to use them. So the software programmers are not going anywhere. They just became a little bit more sophisticated because now he needs to connect there. He needs to understand how the cloud system works. He needs to kind of know what servers he will use, when he will use, whether his data is going to be protected. If he's using one server and if there are multiple people who have logged into the same server, how is he going to protect his data, his program? How is he going to bill his customers when they use his programs, and so on? So there are multiple layers of sophistication that has come in, which makes the game more interesting. It's just that we are not going to have those servers in our backyard. These are all going to be sitting somewhere else, where we do not know at this point. I mean, people are there still. Physically there will be people who manage these servers, but most of the software engineers are now going to be using these cloud servers from a remote location, and the sophistication and the sophistication of using these servers has become multi-fold. So this become more complex in a way, and we need really smart guys to do that, to manage them, to write programs on them, and to and to distribute it to the customers. So cloud computing is a huge area that is still growing. We are now talking about virtual reality applications. Can I walk into a store today? We are all talking about COVID and everything, now contactless and everything, right? So should I really walk into a store, or can I sit in my house, put on a nice goggle, and then I see 3D image of the environment in the shop? Will I be able to shop sitting in my home? But when I put on those goggles, I should be able to see whatever I would be able to see when I'm in the store. Can I walk around? So people have started. So that is essentially possible only because of a very, very powerful cloud system. The kind of compute power that is required to render that kind of graphics for you is not available on the goggle right now. So VR is something that is picking up, and people are still figuring out business applications for it. Now it's a fancy, right now it is in this fancy stage where people are playing around with it, but there are some really, really useful use cases which can save millions of dollars and create millions of dollars if people started adopting it. And then it is now people are trying to figure out how to write programs for such applications, and then that is going to come out. On security, you are wearing your health band, you are wearing people are talking about smart clothes, people are talking about medical devices which are going to be monitoring you all the time. Now all of this data is going to be sitting in one of these servers here. So how do I ensure that the data is secure? That's a huge area of security that comes in. The moment I put data on a cloud, on a network, that is available for anybody to look at, right? So we talk about encryption. We are, the logins and the passwords are the basic of the basic, right? The data, when it goes through these wires to the servers or through your mobile towers, anyone can listen into the data. So how do I ensure that I don't listen in? Somebody does not listen in. How do I'm doing payments all the time, right? I'm using Paytm, I'm using Google Pay, I'm using something else, Phone Pay, and so on. How do I ensure that my bank account details are not revealed to anyone who's trying to steal that data? And believe me, there are a lot of people sitting out there just sniffing through the data packets that are going through so that they can identify and take out those your bank details or your photographs, and they, for whatever use that they want to. So there is another huge area that is emerging, which is to protect this data. It's called as cyber security. How do I ensure that people are not going to attack these servers? These servers are online all the time. It's on, it's connected. Millions of people are connecting to it and doing various operations on it. How do I ensure that one person is not going to steal somebody else's data which is sitting in the server, right? So, and products, for example, when I make a health band or a smart device, smart TV, for example, there's a company which wants to launch a smart TV which is kind of going to be connected onto the internet and all that. Now, how do I ensure, how is the company going to ensure that the TV is not going to send data to the wrong set of people? How they ensure that somebody is not getting into the TV through because it's connected, and they ensure that they are not going to take data out of the TV, because that data will be my personal data, right? I'm going to be logging into the TV with my Gmail ID. The moment somebody knows that, okay, gets into the TV and knows my Gmail ID and my password, for example, if the TV didn't have enough protection or security, that can be used to go into my Gmail account and say if my Gmail account is connected to my bank account, somebody's, he has now access to my bank account also. So any weak link in this chain, if I'm going to log in or give my personal information to any device which is already compromised, then the rest of the data is not very difficult for a hacker to take. So every company is now going to start thinking about, how do I make a device which is secure in the cyber world? We need cyber experts to consult with them, to build them, and then work with them to ensure that the product is secure enough. Apart from the usual, if it is a TV, yeah, I need to have a Ultra HD or HD or a 4K screen. I need amazing speakers, I need amazing colors and blah, blah, blah. But now the new requirement that is also coming in is that it has to be secure. If I put my password into this TV, it is not going to give it to anybody else without my knowledge. So cloud computing is evolving in multiple areas. And we see that in the next few years, this is going to be a huge area where people will start focusing, because almost all the IT companies now are thinking how to move their existing applications into the cloud, how to port the data into the cloud, how to take the existing data into these cloud systems and ensure that their clients are served securely and with more features and whatnot, right? So that is cloud. And let's take a step back into the data again. Now, when I have to process all this data, when I say that this cloud system is going to process all this data and give me some value out of it, it's not that I'm a computer science engineer, I can write great programs. I need to understand statistics. I need to understand many more mathematical concepts. I need to understand if I'm building something for a TV company, I need to understand how a TV works. If I build a medical device, I need to understand how the medical community is going to look at my product. So a lot of domain knowledge also needs to come in. So I need to understand a lot of computer science and how to process this data, because when the data comes in, it's never clean. Somebody would have written my full name, somebody would have written my initials, somebody would have written half of my first name and so on. So that's pre-processing. How do we maintain this data? If this data comes in, this is nothing technical. How do I just maintain this data? If this data comes, this is classified as personal data. This is classified as health data, which is highest level of classification. This data, even if it is out in the market, in the internet, it is not a big problem. Maybe your name is not a big deal, but your name along with your address is a no-no. It's a personal information. Name with your bank account, definitely no. that's very highly confidential data. So how do I ensure that there are enough systems to ensure what kind of data it is? If this data gets leaked, what do I do? How do I limit my damage, and so on? So that is an entirely different area that is evolving in the form of what we call as data governance, data infrastructure. How do we even maintain this data? As I said, 15, 20 years back, data was either a number or a word. Now I have video, I have pictures, I have audio. So I have to have information to ensure this data is infrastructure to ensure this data is saved properly, retrieved properly. If something happens to the server, it is backed properly so that I can take the backup from somewhere else, and so on. So that is what happens when you log into an Amazon or a Flipkart or any of these websites. Your data is always there because they have taken enough protection to ensure that your data is safe, and especially your bank details. You provide your credit card details on that, so they have to be extremely careful, and they do take care of it. So these are all, and then there are people who really understand how to protect the data. They understand how to ensure that there are no leaks. There are people who are constantly trying to hack into their own systems so that they know where are the weaknesses. They are looking at monitoring at who's logging in, who's not logging in. Is there any abnormal activity? You might have seen many times when you log from a different laptop, you will be asked to answer a few more questions than what you would really do, from a normal login perspective. So there are people who are constantly looking at these kind of things, and these are all different opportunities that are only going to grow because of the adoption rate of such technologies. And when I say that, people are looking at the patterns, they are analyzing the way that you're logging in and all that. There's a lot of statistics involved. There's a lot of mathematics that goes into understanding, okay, there is an abnormality there. There is, I always see this person logging in from, say, Delhi, but suddenly he's logging in from Chennai. How do I know about it, right? So I need to write an algorithm that will keep monitoring and then raise a flag saying that, this person is suddenly logging in from Chennai. Let's find out if he is the same one or not. And it's a bigger alarm if there is a 2 attempted logins in between in the same time. It is physically not possible for that person to be not to be in 2 places, right? So if two logins are attempted for the same login, then they should block it. So there's a lot of mathematics that goes into understanding and identifying what is going on in the system. It's not just for security. For example, what I've shown here is typically, I'm going to talk about the story here because I just put a couple of pictures to explain the story. So if somebody was trying to make a product and launch it into the market, and he needs to study the market, he needs to go to sample customers or prospective customers and say that, okay, if I make such a product, will you buy it or not? So he's going to collect a lot of data about it and then come and say that, if I make a product, say in blue color, people are going to buy. Say if I do it in black color, they are not going to buy. So that becomes an input into my product design and development. So a data scientist would be required to collect this data, understand the data, and give input to the product manager saying that this is what is required in a product. And then that goes into manufacturing. Again, in the factory, when the product is being made, they will start plotting out, if I make 100 products, how many of them are working, how many of them are according to the specifications, and how many of them are not. So that gets plotted. And then they say that, okay, on average, 99% of my products that come out of my factory are as per specifications. 1% is not, maybe. So how do I then go and reduce that 1% to 0%? So For that as well, you would need a data scientist to understand what are all the parameters that needs to go in, what should be measured, and whether they are measuring it. And once they measure, they get this data, and then I understand the data and say that, okay, this is a good product and this is not a good product. This is as per the specification, this is not as per the specification. Again, a data scientist would be required to understand this. A data scientist is a very broad name. In fact, even within data scientists, there are people who will only prepare data, people who will create the infrastructure for the data, how to store it, how to collect it, and how to analyze it. And then there are people who write algorithms, because the number of variables that you are getting for each set of data will differ for different applications. So there are data modelers who will, if you give him a bunch of data, he's going to say that, okay, there is X amount of video, there is X amount of data, numbers, there is X amount of characters. This is how we will correlate each of them. So there are data modelers. So data scientist is a broad term, and under which there's going to be a lot many more classifications which you can specialize in. And I've given I'm just showing some of the areas, deeper areas like Python and R and other programming languages. These are languages which will help you to understand the data better, which will help you to write algorithms and programs to understand the data. Then you have classification models, you have regression models. These are all core mathematics. So if somebody with a very strong mathematical background can become a data scientist. So I mentioned about machine learning here. So machine learning is a subset of data, actually, data science. Okay, so I spoke a little bit about this slide already. We spoke about IoT, faster networks, cloud computing. The amount of the data that is coming in is going to be used for product development, maintenance, fraud, and security that we spoke about just now. Machine learning is a part of data science. Machine learning is to, if in the previous slide I just showed this this screen, right, where there is a red line and there is a simple straight line fitting for a set of variables that was plotted on an XY chart. Now, this is that computer is programmed and it has fitted a line and it is showing to me. A human being is looking at it and saying is going to take a decision. What if I leave that decision-making process also to the machine itself? This is where things become more interesting. Initially, I just had data. IoT machines came in and then they started giving me a lot of data. Faster networks ensured that I get real-time data. Cloud computing ensured that I have this data processed very well and I have compute systems available. The volume is an amount of data. The velocity is the speed at which I'm getting the data. Variety is the type of data that I'm getting. Value is the business value that I would get out of data if I understand it. And veracity, very important. How true is this data? I always have to apply my logic to understand whether this data that I'm getting is true or not. So all of this will go into a number of applications. I'm going to talk about more applications in the next slide, especially from the place where the machine learning starts, right? So I process the data, I made some regression algorithms, I forecasted some numbers and so on. I'm happy about it. But what if I let that also to be done by the machine itself? Making decisions. My machine, if it is going to start understanding the data by itself, that is when it is starting to mimic human intelligence. But if it can mimic human intelligence, but can it think like a human being? Will it have emotions? Will it have feelings? Or will it just go like a machine, right? It's a machine. So will it be only 0 or 1? Your class teacher can probably look at your handwriting and then give an extra marks because okay, the answer is not entirely correct, but then he's put his effort in writing it beautifully. So let me give him extra 2 marks. That is not going to happen with a machine. That is what I'm showing in this picture. In most of the competitive exams, you're just going to mark with your pencil like this, right? In those option choices. That's because the machine is not going to understand who you are, how you have written, and all that. Whether your answer is correct or not is what is getting evaluated. So that and these kind of answer sheets are typically evaluated by machines only. You put the answer sheet into the machine, it is going to see where you have marked with your pencil. It will say, okay, he has marked A, which is correct or not correct. Beyond that, it is not going to take any decision. So it cannot act humanely. It cannot think like a human being with emotions. But still, there are applications which are very, very useful, and we are accustomed to with machines. Your Alexa, Siri, Google Assistant, all of them fall under this category. Every time your plane is flying, your pilot is only taking off and is landing. The rest of the time, the plane is flying by itself. In many cases, or there are, a full-fledged aircraft today is capable of landing by itself also. This happens in conditions, in difficult conditions, when there is there's a lot of environmental factors. There's a hurricane, there is a low visibility. The plane can land by itself. So it'll take a decision on whether to what speed it should come in, whether it should fly low or high, what are the positions of the wings have to be. Everything, it takes decision and it will land the plane, right? So we are in a place where the kind of programs that we have written and the kind of compute powers that we have are safe. We trust them to save with the lives of people when the plane is landing. Predicting traffic is the simplest of all. Given the kind of applications that we see, predicting traffic is very, very small. Showing routes for you is relatively very simple. Even if you lose your way, you can always come back. So it's not a big deal. It's not so critical. But there are medical decisions that these systems will taking. They will say that, okay, so there are medical systems where a disease is diagnosed by the machine. It's simply very difficult for a human being to identify whether that disease is present or not, but there are machines which are now going to say that yes, this person has cancer or this person has something else. So this is where we cross from a data scientist to artificial intelligence and machine learning. The machine is now starting to do what a human being is supposed to do. We have not yet reached a place where the machine can completely take over in most of the situations, but we are definitely getting to such a place. So this is how things are happening now. So you have data science, which is a much bigger universe. Then you have artificial intelligence, where machines are now trying to take decisions. Machine learning, so somebody has to teach this machine, right? So the machine is going to now say that, okay, this is what I think. This person has written, this kind of an answer, and I think that it is correct or wrong. Now, there is an entirely new set of careers that are evolving, where you go and say that, okay, train these machines. You will say that, okay, the machine has said something correct or something wrong. In fact, there are commercial systems available today where they will actually pay you if you sit there and answer questions for the machine and help the machine to learn. So like a baby, this is where we are almost getting to a place where we are trying to mimic human beings, mimic human brain. So the way we understand how we learn is what is modeled into the machine also. So a baby will learn that if it cries, it's going to get milk, right? So every time it cries, it knows it's going to get milk, and if he's not going to cry, then it's not going to get milk. So that's a very simple, basic question, right? So similarly, the machine also needs to understand what are all the various things that it can do for certain output. If I have to say that a student is passing this subject exam or not, the initial few set of questions, the teacher has to actually tell the machine that, okay, this is a correct answer, this is not a correct answer. So the machine will keep on building that what we call as network, a neural network, which is how our brains also work in a way. So every time somebody says that, Senthil, you are correct, my, somewhere in my brain it's going to say that, okay, Senthil, you feel happy because he said it is correct. So I want that happy feeling again, which means that my neural network, that portion of my brain which feels happiness, becomes stronger. That those connections in my brain become stronger. So similarly, a machine also makes those connections, and somebody has to train it. Somebody has to give it a lot of data, so that by looking at the data and then classifying it, it will say correct, wrong, correct, wrong, correct, wrong, and after some time, the machine would have learned how to take that particular decision. But that is only one decision. How do I make it understand millions of things, which a human being will be able to do very easily? We have still not understood how our brain works, but we are taking some small steps towards that, right? So there are a lot of careers that needs to that will be built at different levels. Somebody has to teach it, somebody has to give its data, somebody has to um, teach new skills to it. So there's, in Amazon, there's something called skills. If you tell Alexa, switch on my light, that's called a skill. And who made that skill? Somebody wrote that program saying that if it hears that Alexa, switch on the light, it should do this. If he says that in Hindi, if he says that in Tamil, if it says that in Oriya, Kannada, whatever language, somebody actually went and taught Alexa that if somebody says light on kar do is equal to switch on the light is equal to go, do something physical so that the light switches on. So all these have to be trained for a machine. So either you could be the guy who's training, or you could be that guy who's programming what the trainer is going to tell you. You could be the programmer who's going to make those neural connections, neural networks. So it's the field of science is called neural networks. It's been there for almost 50-60 years, but now it's when we are trying to make sense out of it. So at different levels of sophistication, there's a lot of jobs that are going to evolve. Again, the basic is going to be computer science, the basic is going to be mathematics, right? And then deep learning. Deep learning is a place where now the machine is not necessarily going to need you to tell whether it's correct or not. It's going to learn by itself. It's going to observe the variables in the environment and then see whether it's correct or not. Many times it is going to be wrong, but over a period of time, it will say that 90% of the time, if I take this path, it looks like it is going to be correct. So let me do that. So those are the systems that you hear, like Go, like the IBM Go, right? So it went and it is actually playing against a human being, either a chess game or a Go game, and then it is trying to beat a human being, right? That's very, very difficult. It needs millions and millions of calculations before it can move something on the board. When say in a chess game. Now that is a deep learning example, because a machine learns by itself. Because in chess, if you look at it, there are 64 squares. You have 32 coins. Anyone can be in any position. There are millions and millions of combinations that will happen for every move that your opponent is going to make. So the human brain understands a very well-trained chess player is able to identify and play very, very nicely, right? He knows what are the moves, what he should do to get to win the game. But to make a machine do that is very, very difficult, because we still do not know how our brain works when we are playing chess. So and it's not possible for us to teach the machine right now, because these are all situations that I I don't understand, how do I take a decision, right? So how do I teach the machine? So then I tell the machine, you go by learn yourself. That is deep learning. It will not be correct all the time, but over a period of time it will learn. And again, it is in the domain of neural networks. So a number of these kind of sophisticated jobs are going to be created. So artificial intelligence and data delivery is not going to replace humans as such. Human resource managers, for example, even though now we are doing all these learnings and programs on Zoom today, why have not the schools started? When the school said that we will do online coaching, we are not very comfortable with it, right? Because at the end of the day, we know that the teacher standing in front of us and telling us and teaching us has a lot of value than I just listening to someone on the computer. That is where the human interaction and the values that come out of it is not, we are not able to program them into any of the machine. Similarly, in a human resource environment, if in a company, if the HR manager has to handle a situation, there are a number of human emotions and feelings and parameters which a machine will not understand. A marketing manager trying to sell a product in the market will understand his customers better than a machine, right? How much ever of what we call as experience, customer experience, and how much ever of parameters that you build in to understand a customer and personalize the packaging to him, a marketing manager looking at a customer will understand his needs much better than a machine. Similarly, leadership, similarly, writing, software development, software is not going to be developed by itself. Creative jobs like graphic designers, that is not going to be replaced by AI anytime soon. So mundane work, right, like classifying a check, classifying data, some of them can be scripted and automated. But if you are starting to apply artificial intelligence as such for any of these applications, it is only going to increase the sophistication of the jobs that a human being would do, right? So once we start doing that, now I said that there is data, the machine is going to learn data. We will teach the machine, and then I said the machine will learn by itself, and it's going to create so many jobs. Now, how new jobs are going to get created and how existing jobs will get redefined? If AI, for example, there is a robot and it is doing something, will it follow the law? So somebody has to program that you cannot cross the street without looking left and right and all that. So it's very simple, cross the street when there is possibility that you can cross without getting into an accident. Will the robot follow it or not? For example, if I had taught the robot that this is a no, it's a clear no. But when I tell the robot to learn by itself in the deep learning environment, it's a probability. The robot would say 70% of the time I'm correct, 30% I'm not correct. Let me take a chance. Again, the machine is going to take a decision by itself in that area, in that circumstance. So then will the robot take the right decision or not? What if it goes and gets into an accident, right? Then if it gets into an accident, how will we manage that? Because there's no human being involved. Will I go and catch hold of the manufacturer of that robot or the guy who wrote the program for the robot or the guy who's actually owned it, the guy who bought it from the store, right? So a lot of the other areas, the so-called non-technology careers, right? Law will change. The lawyers will have to change. People who look at understanding social sciences, people who understand how human behavior works, right? Cognitive sciences, psychiatric sciences, all of them will have to now start looking at how artificial intelligence is going to affect their lives, right? Physicians, the computer is going to say that, 70% of the time you give paracetamol, this is going to be fine. But the doctor looks at the patient and he feels that he cannot prescribe paracetamol, right? So then he has to go against the computer there. Then will somebody is going to come and tell him, you should have followed what the computer said and you should not have done what you know, right? If then how do I manage this kind of problems in real life, right? That brings it into a very interesting application that is everybody is talking about right now in the world, which is self-driving cars. Okay, I buy a car, it's going to drive by itself, and I'm going to trust my life with a car. It's going to take me on the highway at very high speeds, and I believe that it is going to be safe. It will know when to stop. It will know what are the speed limits and so on, right? But what if it needs to take a decision which is going to put my life in danger, right? So I'm going to ask a question, and then Arun is going to show you a poll. So I'm going in an autonomous car, and somebody is somebody is walking along the road. If I crash into that person, he will be killed. But on the other side, I have to crash into a wall because there is a truck in front of me, for example. So will I crash into the wall, or will I crash into the pedestrian? Pedestrian will die if I crash into him. If I crash into the wall, I will be killed, and I don't have the control of the car. What will the car do? Or what do you think the car should be doing?
Okay.
All right.
So I don't know if you can see the poll. 53% of the students for the respondents said that they would crash into the wall, which means I'll take the blow.
Yes. So that is very interesting, right? So the same question was asked with people across multiple countries. So when you take a decision, when you have to program a decision like this into the computer, into the car in this case, it depends on the values with which people are also brought up. And many cases, we do not know how a human being will react in that split second, even, whether the person will just turn the steering or he's just going to let it go. So in this case, it looks like, we have a majority, but not by a huge margin, but still a majority of people who saying that, hey, you know what, it doesn't matter if I die, but I will save the pedestrian. Kudos to you guys. There are countries where people say that, okay, I will look at the pedestrian and see whether that person is a weak person. If the person is fat, I'm going to crash into him. If the person is athletic, I'm not going to crash into him. If the person is young, I will not crash. If the person is old, I will crash. So there are a number of parameters that comes into a human brain, and we are, people are still figuring out how the human brain will take a decision in that circumstance, because that circumstance is going to be a culmination of all the values that person was brought up with. If somebody had told that a very classic thing nowadays is that, a person in a business suit with a nice suitcase and he's walking briskly, I should not go kill him. That is what they found in an European country. They said that if the person is going to be like that, the pedestrian, I will not kill him. If there was a dog and a human being, I will, interestingly, people said I will crash into a human being than killing the dog, right? So we really do not understand how the human being brain is going to work in such a situation. And if you have to program into that car, it's even more difficult for us. But the more interesting question that comes in is, say I crash into the wall and the owner of the car is getting killed in this case, right? Then what is the liability there, right? why would I go and buy a car which will take a decision to kill me than a stranger? I don't want to pay for such a car, right? Um, Suppose I am going to be killing the pedestrian, for example. 48% people said that will kill the pedestrian. If I go and kill the pedestrian, will the police come and catch hold of me or the car? Because or the car manufacturer or the guy who programmed the car, right? So now things are very loose. If the car goes and kills somebody, if as an owner I say that I don't know how, I was not driving it, then if the car kills it, you're not going to hang the car. So who's responsible for it, right? So a number of these kind of ethical questions start coming in. So it has implications on social sciences. So people have to understand that there are people required who will understand how a particular cultural community is going to behave. Somebody in Germany will behave very different from how a person in India or a US or a Japan or any other country, right? So what is their cultural background? So somebody needs to understand and read and be knowledgeable about the cultural niceties in different regions. And then they have to come up with policies. Then they have to come up with the laws, and they have to implement those laws. So all these are all new areas of jobs and fields of study that will be affected by artificial intelligence and data science. This is a classic question that I have asked. MIT is still doing similar um, um, polls and studies to understand how a human being will take a decision in very difficult situations like this. And these polls and studies will lead into policies that will be given to the governments. The governments across the world have already started thinking that there has to be a way to ensure that these machines are brought under the law. There was a recent thing they saying that Amazon and Google are always listening to what you guys are talking, whether it is on or not. Siri and Google Assistant, Alexa are always listening to what you are talking, and then they are picking up keywords to say that okay, this guy is wanting to buy a fridge very soon, so let me show him the refrigerator ads all the time. What that's still very commercial, very nice. It is not too much of an hindrance into our privacy. But what if I say that if somebody says I'm going to kill you, and Amazon takes a note of it, and a few days later that somebody dies, is this can I make a decision that this person went and killed the other person because I already listened to him? So today that's a gray area. We don't know whether somebody is saying something in what context and meaning. For example, I'll tell my friend that dude, I'll kill you if you do this, but I don't mean that I'm going to kill him, right? The machine will not understand it like that. The machine will think that okay, there's a word kill which this guy used. So these are all gray areas which needs to be understood. It is still not understood. We are still trying to figure out, and there is a huge amount of opportunities for people who can understand these areas, to make sense out of it, to make contextual meanings, to make laws out of it and policies out of it, and enable implementation of it, right? So in short, I would like to conclude saying that all these advances in technologies are only creating new and more sophisticated jobs for human beings, and not the other way around. They are not replacing human beings, but they are just going to add a lot more value to the society. And with that, I would thank the audience here. I'm open for questions. I'm happy to answer any questions that you would have on this subject. Arun, over to you.
Thank you so much, Senthil. Thank you so much. I have a number of questions with me, Senthil, that people have asked. We'll have to probably prioritize some of them. I am refraining from writing the names or calling out the names of people who have asked questions, but bring in these questions. Is maths background important to choose a career in AI and data science? That's one. And if we can keep him short, I think we have already exceeded the time. So
Yes, yes.
yeah, please.
Absolutely. If you do not understand mathematics, it will be very difficult to understand the data. That is, if you are going to work on the technology side of data. If you are not happy with mathematics, but you still want to be a part of this ecosystem, you can look at social sciences, you can look at psychiatry, you can look at cognitive sciences, because all of them are also going to be, all of those jobs are also going to be created because of AI. So mathematics, if you want to get into the technical side, mathematics is not required as much if you want to pursue the non-technical side, law, ethics, social understanding, culture, and so on.
Yeah, if I can take a second, I think all of us will need to understand, for kids who are in school at this moment, that we'll have to start appreciating some of these technological advancements. So whether you will be at the user side of it or at the innovator side of it, right? You will have to build appreciation for it. The fact is, some of the largest FMCG companies, the head of marketing is probably going to spend more money in data science today than on advertising, right? So for all of you who are attending this session, please understand that you need to start appreciating. The second question is, which programming languages should be learned for data science?
Short answer, start with Python or R. So these are the most common stepping stones to understand data science. Python is fairly popular and available at different levels, so you can start with Python.
Senthil, one of the students asked you, maybe students is the wrong word. Attendees asked that, you replaced AI with robots while explaining. He wanted to know if AI and robots, or it could be just a slip of tongue, or, AI and robots are two different things. So he just wanted a clarity on that.
Yeah, so when I say robots, they are machines, the physical machine, right? I use the word robot so that you can visualize it better. Physical human thing, human looking thing that walks into your house, you will call it as a robot. And whatever it does is because it has AI in it. It has artificial intelligence in it. I use the word robot to explain that difference so that you can visualize what I'm talking about. Somebody sitting somewhere in the cloud and Alexa giving you an answer is also artificial intelligence, and it is also a robot. But you are not seeing that robot because that robot is sitting as a server in some cloud form. So that's the distinction. But whatever the robot does is still artificial intelligence. There is this room cleaners that are available right now, right? The floor cleaners, you just put it on the floor and it's going to sweep your floor. That machine also is a robot. It is also having artificial intelligence because it knows whether it has cleaned a certain section of your floor or not. So in that way, the hardware is a robot, the software is the artificial intelligence.
Okay, a lot of students, I'm digressing for a second and then coming back to you, Senthil. A lot of students asked, if you're doing sessions on a variety of areas. Yes, we intend to cover a lot of ground, right? Not restricted to a select set of careers. So this is what our schedule is for June 17. We have a career, another professional from the industry coming and talking about hospitality, or careers in hospitality, and then we have next Sunday a discussion or a panel discussion on careers in design, right? The next question, Senthil, is, and this is getting a little technical, and I'll respect the curiosity that the kids have. What is recapture verification that makes you select photos and ask if I'm a robot or not?
Interesting. That's a very, very good question, because What happens in these websites is that these websites do not want programs to log into them. Like the way you are putting in your username and password and then press login to get access to your, say, your bank account. I do not want a program to log into your bank account, right? Because it's a very secure system, secure data that is there. And what if somebody gets access to that, your personal data, login and password, and then tries to log in by itself? So this reCAPTCHA thing is something that a program cannot understand. If there is a character word that is displayed and you are asked to type out that word, it is very difficult for a program to understand what is that word. You need to have optical character recognition, and many cases the words are blurred. So if my eye, a human eye, would read it as R, but the program cannot understand it as R if it is blurred. So that comes the human ingenuity in the brain, right? The brain will understand, okay, this is what the guy would have meant when he wrote it. So those kind of niceties a program cannot do. There are sometimes pictures shown, right? They will say that wherever there is a traffic light, go click it. Now the program has to understand what is a traffic light. It has to see whether those green, red, orange things are there or not. It's very difficult to program something like that. And if there are, and then I have to identify how many pictures are there, and I need to go click all of them correctly. So it's very difficult for a program to mimic a human being in that circumstance. So that is why they show the reCAPTCHA, so that only human beings will log into the system.
A couple of, if you can take this up very, very briefly, can AI be biased?
Absolutely. If you are going to, so the way AI is evolving right now is through deep learning. Some of the basic things that the AI doing is what the AI does today is straightforward programming. We train the model, we say that this is correct and this is not correct. But a human life is never black and white, right? There is never going to be like this is correct and this is not correct. If I cross the white line at the traffic signal by 2 centimeters, the policeman is not going to say anything. If I cross it by 10 feet, he's going to catch me, right? So AI is not going to understand those areas. So the way it is trained will define whether it is going to be biased or not. Again, like a human baby, the inputs that it is going to get when it is getting trained will define whether it is biased or not. And there's a very good chance that it will get biased. And that is the reason why the governments need to pitch in to enact such laws to ensure what is okay and what is not okay.
A very quick yes and no maybe question, is SQL necessary for data science?
Yes. Absolutely. You need to know how to deal with data.
There is a splurge, right? So I, for everyone's sake, what I will do is I'll take 3 questions where I'll pass on the speaking rights to the students or parents, right? Last 3 questions, please keep it short. And if you have to ask a question, raise your hand. The first one goes to Karandeep. Karandeep, please ask your question.
Hello, sir.
Yes.
Sir, good afternoon.
Good afternoon, Karan. Please go ahead.
सर मेरा क्वेश्चन ये था कि मैं अभी 12th में हूँ, साइंस स्ट्रीम में.
Yes.
तो अगले साल मेरी वैसे जेई का एग्जाम है. तो मुझे आगे अपना जो करियर है वो एज अ कॉस्मोलॉजिस्ट परस्यू करना है. तो मुझे उसके थोड़े से स्टेप बताओ कि कैसे मैं अपनी अंदर कॉस्मोलॉजिस्ट का करूं, और मेरा अगले साल जेई भी है तो उसमें भी मैं कैसे अपनी रैंक इंप्रूव कर सकता हूं.
Okay, guys, there is a there is a very, I'll request that let's, for these, we can't really ask any question to anybody. Please, let's restrict it. Karan, I actually written back to you in your Q&A also. You'll have to allow me to come back on this question. We will respond to you, but not now, not here. People are in for a different reason, right? So if you have, your question needs to be around new technology, careers around there, data science and all. Let's not, don't ask me a question right now on medicine, right? I am going to Gunin now and hoping that, we are on the same page. Yeah, Gunin.
Hello, sir. We have. I'm in 10th and I'm to make career in computer science. What we have to do?
Just go ahead. Gunin, can you repeat your question, please?
Gunin wants to, he's in class 10 right now and he wants to pursue a career in computer science.
Yes, sir.
Yes. To begin with, you should choose either computer science or a science stream for your 11th and 12th boards. That would be your first stepping stone. And parallelly, I would suggest that you start programming languages, but start looking at analytics courses, analytical skills, not analytics as such. I'm talking about logic and analytics. So start focusing on mathematics, start focusing on logic building. That will help you to in the next 2 years to look forward to get into a computer science course.
Anushka, you're next, please.
Hello.
Yeah, Anushka, go ahead.
Good afternoon, sir. So I want to ask if there is scope of medical and AI together. I mean, what kind of fields we have in medical with AI?
Yes. So in the Venn diagram I was showing, there was computer science on one side, I had mathematics, and then on the other side I had domain, right? So artificial intelligence is a technology, mathematics is a tool, and domain is the application. So one of the applications I was talking about during the session was identifying diseases. When there is so much amount of data that is coming in, how do I know whether that person is having that particular disease or not? So these days there are artificial intelligence programs that identify such critical illnesses. Finding drugs, for example. Now, because of COVID, there's a lot of research that is going into understanding the virology of COVID. There's a lot of research that is going in understanding the genetics or the study of DNA to identify because of what genes, what characteristics evolve. So all of this is again very data intensive, and medical field is going to benefit hugely from artificial intelligence. Does that answer your question?
Yeah, I'm sorry. I've actually taken the speaking rights. I think you've answered it.
Yes, thank you.
Amog, and then we will take Shobit for want of time.
Yes, good afternoon, sir.
Yes.
Sir, I just wanted to ask, I am in class 10th right now. From which class, from when I should start preparing for IT, and how should I learn coding?
Okay, so if you are planning to get into, I think you meant IIT, right? So I would say that, probably towards once you get a grip of what you are studying in your 11th standard, you can start preparing in parallel for the JEE exam, and start looking at what are the what is the pattern of the exam. Start looking at the applications, the kind of questions that are being asked. Maybe start doing mock tests towards the end of your 11th standard. And by the end of 11th standard, you should be ready to take a JEE exam, at least mock exams, so that in the next 1 year, you can focus on improving your grades on it. So you are actually in the right place to start.
Okay, great. Shobhit.
Yes, sir. So I wanted to ask that I'm in 10th standard, and what will be the fate of graphic design and drawing in the field of AI? And how can I make myself set apart in the interview for an AI company? Because I mean, I'm in 10th right now, and I know basic Python and programming. So
Right.
do I have to learn multiple languages?
It will evolve. I mean, to be frank, you're still in 10th standard. By the time you are sitting in front of a panel for a job for in an AI company, I'm sure everything would have changed. So even today, there are models where you don't have to program anything, but you can do AI models. But you need to understand the mathematics behind it. So what I would suggest right now is to focus on your mathematics fundamentals and your programming fundamentals. And the way it will evolve in the next few years, you will be able to grasp everything if you have these two in place.
Shobhit, just wanted to understand, when you're talking about the fate of art and graphic design in the future, which side are you? Do you have interest in the fine art side of it, or you're talking about as a science student? You can type in your question. Yes, Devika, if you have something else, I understand we've exceeded. You can excuse yourself. Okay. One last with Prachi, guys. My apologies for not being able to take up all. My request would be if you can drop me an email at arun@npoca.com. I will try and answer most of them. We will take Senthil's help in answering some of your technical questions. Right? Prachi, you have the speaking rights, and this is the last question for the day. Tushar Khatri.
Yes, sir. Good afternoon, sir.
Good afternoon. Please go ahead.
Sir, I basically want to know that now I am in my 12th standard, and when I was in my 10th standard, I used to learn like scripting language front end like HTML, CSS, and now I'm basically going on with Python. So I just want to ask that to pursue a career in AI, do I really need to go look forward for JEE exam?
Not necessarily. So JEE exam is for IIT, right? You could do your artificial intelligence related courses anywhere else as well. So if your goal is to become an engineer from an IIT in these areas, then yes, start preparing for JEE. Otherwise, I think you already started programming on Python. You will start looking, you would probably be aware of the libraries that are available. So you start finding out interesting use cases or problems to solve, and then see whether you can build programs out of it to solve those problems.
Yes, sir. I just basically want to be a full stack developer.
Yeah, a full stack developer is very different from an AI developer.
Yes, sir. But basically, I'm going on with this, but I can look forward for AI too.
Yes. So I what I would suggest is start building on what you know right now, because a full stack developer, you are actually going into a LAMP or a Angular or a React stack kind of thing, right? So I would suggest if you have time, you can learn all of them, but make your foundations very strong on your Python skills and your mathematics, your regressions, your algorithms. That will take you a long way to understand this subject. I'm saying this because it's at least going to be another 3 to 5 years before you are out looking for a job in the space. And there's a lot of changes that is going to happen in the next 5 years. So make your basics strong, make your mathematics and your programming skills strong. Your full stack skills is going to be changing. 5 years down the lane, we will not even know whether we are going to have the UI or user experience in the way that we are having today. So Angular and React are good for today, but 5 years down the lane, we really don't know where they are going to change.
Correct. In fact, I think the only definite thing in the whole story is they would change, right?
Yes.
Guys, please understand that you're living in an era where you cannot have fixed ideas about a particular career. There's a lot of study which says that in fact, if you look back around you, you will find that most of the top 10 careers that exist today were not even there when I was in school, or when Senthil probably was in school or college, right?
Yes.
So the type of jobs will continuously evolve. What is important is we understand which is the direction that I want to get into, and rather than being fixed about a particular career, you need to know which direction am I going to get into, right? Am I looking at a maths-based career? Am I looking at a technology-based career, right? What would be the important success factors if I want to pursue a career as a technologist? Look at someone like Senthil, for example, engineer, MS, MBA. What most of you who will be successful in the future, right, would do is you will create your own niche. What COVID has done is also changed the world of work. And we aren't sure of if you're going to have one more situation like this, the whole world of work might change completely, right? And hence my request at this moment is for those who are in class 10th, 11th, 12th, what you have to do is build strong basics first, right? Please choose careers intelligently. Do not choose a career because you've created some kind of a hierarchy of good and bad careers. Most of the jobs in future, for example, would require a high level of creativity, right? So my request right now, do not get over, do not overemphasize on a particular type of career, because there is no guarantee that that particular job will exist in the future or not. One of the reasons why we did not restrict students of streams into this section in this session was, I think even if you're a humanities student, even if you want to get into fine arts, you are not necessarily using the paintbrush alone. You will be using technology. And hence, what is certain is all of us will need to be open to the idea of using technology. That is something which is unavoidable, right? I think it's been a long day. Thank you so much for all your patience. Thank you so much, Senthil. Really appreciate you taking out time and being so patient with all the questions. So thank you so much. I would request all of you to keep your, keep checking on the future sessions at npoca.com. You can spread a word to your friends. You can let your school principal and counselors know. For now, these sessions are open for all. However, once the schools open, these would be beamed into the schools, right? Thank you so much, everyone, for taking out time. I hope the session was of value to you.
Thank you so much, Arun, for the opportunity. Pleasure is mine. Thank you so much for all for joining, and we have exceeded our time a lot, but thanks for your patience as well.
Thank you, and I'm closing the session. Janish and a couple of others will take your questions. Bhavna, answer is no. If you're wanting to be someone who's good at that job, answer is no, son. Bhavna, right? And thank you so much. I'm closing the session. See you all in the next session.